In this lab, we'll investigate resistor circuits and meters. In each section of the lab, we'll build a circuit consisting of a voltage source connected to some resistance. We'll put an ammeter inside the circuit to monitor the current that flows. If we want to measure the voltage dropped across a resistor, we'll use a multimeter set to measure voltage. This lab has 3 sections. In the first, we'll verify Ohm's law for a single resistor. We'll check that the voltage drop across the resistor is proportional to the current through it. In the second section, we'll verify Ohm's law again, but for combinations of resistors in series or parallel. So in this section, we'll see how resistors combine to create effective resistances. In this lab, you'll use what's called a breadboard to connect your circuit elements. Each set of holes on the breadboard is electrically connected, so all of the holes in each set are held at the same electric potential. To connect a basic circuit, say to put a voltage across a resistor, you'll snap one of the resistors across 2 different sets of holes and insert the leads of your voltage source into either side. When you do this, current will flow from the more positive lead through the resistor and into the more negative lead. The amount of current is determined by Ohm's law. To measure the voltage dropped across this resistor, just place the 2 leads of the multimeter into the 2 holes whose potential difference you want to measure. To measure the current through the circuit, all of the current has to go through the multimeter, so we'll put the multimeter in series with the part of the circuit we're measuring the current through. Set the multimeter to measure current. In this setting, the multimeter has a very low resistance, and you can ignore its effect on the circuit you're measuring.